Hey, hi everyone. Good morning.
Morning.
Good morning.
Okay. So, guys, have you gone through the recording? Do you have any questions? All right. Okay. So, yesterday we discussed about logistic regression. So, primarily it is a statistics-based model algorithm. So it is very much similar to a linear regression, where linear regression helps you to predict the numerical uh, variable. Logistic regression basically helps you to predict the binary variable, okay, a categorical variable which has only two classes. Uh, and yesterday we discussed about how basically this logistic regression transforms from a linear model to a non-linear form, and again from non-linear form to a linear form. So from linear to non-linear, we use a logit function or logistic function. So we have seen the equation yesterday, and that is the equation of a sigmoid curve or a sigmoid function we call. And then we have seen how that sigmoid function again converted back to a linear form with the help of log of odds ratio. So log of odds ratio is a log of ratio between the probability of the success by probability of failure. Okay, and then we also discussed about a cost function. So all these algorithms, their primary objective is to minimize the cost. So cost is nothing but you can consider it as an error, overall error. So 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 this whole process of minimizing the cost is known as learning. That's the reason these all algorithms are called as machine learning. So as we study till the point uh, we score well, okay, we score good till that point in time, we keep on learning the concepts, right? So same way these algorithms, they keep on learning till the cost function is the minimum. So for linear regression algorithm, we have seen the cost function is mean squared error. And for logistic regression, the cost function is minus log likelihood. We talked about what likelihood is. You can refer to the notes or you can refer to the recording to understand better. So we talked about likelihood, then we talked about log likelihood, then we talked about minus of log likelihood, right? So that's the cost function, and this whole algorithm based on the gradient descent, it will optimize the coefficients, um, which gives the minimum cost function. Okay. So today we will see a use case where we will go and train this logistic regression model. And then we have also discussed yesterday some of the evaluation metrics. So today we will see some of those evaluation metrics, how we can use, to evaluate our logistic regression model. All right. So let's get started. I hope you can see my Jupyter notebook. Okay. So this is the same use case, what we have discussed yesterday. So here we are going to predict the churn, customer churn. And here I've mentioned what is this data set is all about. Okay, so these are all real data set which has been shared by some company, for people to utilize that data and to build some model on top of it. So now these are the basic packages or the libraries which you will require, to train this logistic regression. Definitely we require sklearn, and we require pandas, numpy, okay, matplotlib we require, for plotting, okay. And this particular line of code, why we use this. This is used to plot any particular graph inside the notebook. Okay, so inline means inside the notebook the plots will be generated. Otherwise, it may render outside the new Jupyter notebook, and the separate window may open, for that plots to render. So this is about the data set. Go through it. So basically, it comprises of the customer information. If you see, yesterday in the slide, we have we have shown, we have seen a limited data, but there are so many other parameters or other variables are also included in this particular data. Okay, so it has a demographic details. So demographic details is all about gender, age range, location and all those things. Then customer account information, how long they had been a customer, what is the contract, payment method, monthly charges, total charges, and all those, and what kind of services they have signed up with. So all that information is also there. And finally, a target variable, the customer who left within the last month. Okay, so that is the final column which we will consider as a target variable, and this is something which we will try to predict with this model. Okay, so firstly, what you have to do is anytime whenever you are importing the data, first you have to do some kind of analysis of that data, whether the quality of that data is good uh, or up to the mark, or if there are any discrepancies. If there are any discrepancies, then you have to go and correct those discrepancies. One discrepancies could be, the data types. So sometimes the data types would not be properly identified by the Python when you load the data into into the Python environment. So so you have to go and cross-check the schema. Is the schema correct or not? If not, then you have to go and change the schema. Okay. All right. So now here I'm taking just a few limited columns. Okay. So these columns currently I'm taking, I just showing how you are filtering the data. But behind this, lot of uh, what do you say? Lot of things goes behind this. Firstly, you have to understand the domain. You have to check with the stakeholders, your business, to understand which of the variables are important. Or else you have to go and conduct some kind of statistical tests, okay, which we have seen, right? You have to go with correlation analysis. You have to go with ANOVA test, chi-square test to understand which of the variables are significant. And based on that, you have to identify those variables. So this whole process is called as variable selection. Once you check the data, if the quality of the data is good, then the second step is go and select the variables, important variables. And the important variables can be selected before the model training and even after the model training. So after the model training, you have to go and check the p-value, which we have seen, right, in the linear regression. If you print the model summary, you will understand which of the variables or which of the coefficients are significant. So wherever the p-value is greater than 0.05, so that means that particular variable is not significant. Okay, so in that case, you cannot reject the null hypothesis, which states that um, your coefficient is almost equal to zero. It's kind of equal to zero. So in that case, you have to drop that particular variable. So you have to perform all these analysis and you have to arrive on the list of important variables which you can consider for your model training. So here I've considered these uh, variables, okay, and then converted this particular variable into integer. Okay, so this is my data now. This is a small data set. So as I mentioned multiple times that the whatever data is available in your database or in the organization, the entire data is not required for your model training. Okay, you need not to go and use the all the variables or all the observations for your model training. You need to uh, take a sample of that data. So sample, we have discussed in detail how we do the sampling. Either you can go with a random sampling or you can go with a stratified random sampling. So you have to make sure that whatever uh, in whatever environment you have to make the predictions, the similar kind of environment from the similar kind of environment you have to consider the data for your model training. Otherwise, what will happen is you have trained the model onto a separate data set and you are predicting that model, you're using that model for predicting the data which is being captured from a separate environment. So sampling is very important. If the data you are not considering in the right way from the similar environment, then your model will not give you the accurate predictions. Okay, so now I've converted this data frame into a NumPy array. So as array is a function which will convert, or else we have seen that you just say dot values, which we have seen in KNN use case. So by doing that also, you can convert your data frame into an array. So here I've even segregated the input variables and the output variable. So this is my output variable, this is my input variable. Now, this pre-processing step is here, it is optional. Even if you do the scaling, there is no harm in it for logistic regression. But for KNN, the scaling is mandatory. Okay, you have to do it. Okay, so here I'm going and doing the pre-processing. So it is I'm doing the standard scaler. Standard scaler means I'm converting all the variables to the same scale. So what I'm doing, I'm converting the values to a Z score. Okay, so that's a formula x minus mu divided by sigma. That's a formula of Z score. So I'm converting all my values into a Z score. So with this, my all columns will be on the same scale. So this process is known as scaling, or we can call it as normalization. Okay, because once you convert your values into a Z score, your data uh, will show a standard normal distribution. Okay, so there's a reason it is also called as normalization. Now, after that, I will split my data. So that is my pre-processing. So pre-processing is also called as data preparation. Okay, a step. And I told you that around 60 to 70% of the time goes into pre-processing or data preparation. This is a very small step or small task what we are doing here, where we are scaling the data. But when you encounter the raw data, a lot of things you have to fix it in the data. You have to deal with missing values, you have to deal with outliers, you have to even convert certain variables into different forms. So we call it as feature engineering. So all that you have to do and make sure that the data, whatever you are feeding it to the algorithm, is right in shape and contains all the important patterns and relationship and the variables. You have to make it sure. So once the data is ready, then only you have to go for model training. And in this process, you have to bring in the functional guy to make sure that whatever variables you have captured or you have considered, and whatever feature engineering you have done is aligned to the business process. Okay, or is aligned to the business. So after you train the model, after that you go and get it validated from the business. Business sometimes reject your solution, saying that whatever features you have selected are not appropriate. Okay, they are not correct. So the data preparation is basically takes a lot of time, because here the business uh, uh, knowledge also come into play, and your statistical knowledge, your technical knowledge, everything, you have to use it to create your training data set. Okay. So slow by slow, we will understand for other use cases. I will show you how we can deal with missing values, how we can deal with some other junk characters in the data. We will also deal with outliers. So step by step, in different use cases, I'll cover those aspects. Okay. So here I kept it simple. So what we have done is we have uh, scaled the data, then we are splitting the data. And this is a very common step in all the whatever use cases we are going to discuss for various algorithms. So this is a standard step. You have to split the data into two parts, training and the test. Okay. So here I've split the data into training and test. And you have to make sure that what is the length of the input variables and the output variable. It has to be same. Okay. So if there is a mismatch, then you will get an error. Okay. So your uh, it will throw up an error. So if you are considering in the input variables 160 observations, and the output variable in the output variable also you have to consider 160 observations. Okay. Similarly, here in the test, 40 input observations and 40 output observations. So now I'm modeling the logistic regression with scikit-learn. Again, it comes under linear model. Yesterday we have seen it is nothing but it's a generalized form of linear model. So it is called as generalized linear model or GLM. Okay, so again in sklearn in the linear model module only you will find this function. Okay, import. So we will import that logistic regression. And here is the matrix, confusion matrix. Yesterday we discussed about this confusion matrix. Okay, so just a second, guys. Sorry, guys. Okay, so we will also construct this confusion matrix, and it is something we need not to do it manually. So there is a function in sklearn which we can use it to create that confusion matrix. So in sklearn.matrix, okay, this module we have seen in the earlier use cases also. So in this matrix, we have a lot of evaluation matrix available. So we have to choose the right evaluation matrix for our use case, and then we have to import those functions, and then we can evaluate our model. So see here, just with one single line of code, we are training the entire model. Okay. So here we'll bring this logistic regression, okay, function. So this is basically the initialization. So what you can do is you can split that into multiple, into two steps also. First, you initialize this particular algorithm. So just like in the linear regression, and name that to certain object, and then you fit that particular object on the training data. Or else you can just put that in a single line also, in the single line of code. So this is where your logistic regression algorithm is getting initialized, and then you are training that model, that algorithm on this particular data set, on the training data set. So when you say dot fit, it will go and find out the optimal parameters. It will use that gradient descent, minimize the cost function, everything it will do. And finally, it will give you the coefficients. Okay. So now I will use those coefficients to predict. Okay, so if you want to print those coefficients, again, you can just say lr dot coefficients underscore, then it will give you the coefficients. Okay, you can refer to the linear regression code. Certain things I will not repeat the code. I will use different functions, but you have to remember what you have done in the previous use case, and the same thing you can also do it in other use cases, because see, the entire this machine learning is for machine learning, we are using one standard package known as sklearn, right? So whatever functions we'll find in sklearn, that is not something can be used only for one algorithm. Those are very standard functions, for example, dot predict or coefficients and all those things, that you can use it for other algorithms also. Okay, so you can try that. So here I'm now predicting, I'm saying dot predict and passing the input variables from the test data set, and now it is giving me the classes. So it is giving me the binary classes. So wherever it is zero, so it is saying for those customers are less prone to churn. Okay, the probability is low, and wherever it is marked as one, there is a probability is high. So by default, when you say dot predict, it will take a threshold as 0.5. So wherever the probability is more than 0.5, it is labeled as 1. Otherwise, it has labeled as 0. Now, if you are interested to have probability values, Then you can use, instead of dot predict, you use dot predict dot proba. If you use this function, it will give you the probability values. The first one is the probability of churn, and the second value is probability of not being churn. Sorry, it's other way. The first one is the probability of not being churn, and the second is the probability of being churn. Okay, so this is how you can consider any of these values, and the sum of these two values would be equal to 1. The probability of success, this is the probability of failure, and this is the probability of success. Probability of 0 and the probability of 1. So the total sum of these two values would be equal to 1. Okay, so if you see here, for initial couple of cases, the probability of 0 is high, right? It is more than 0.5. It is 0.7, 0.9, 0.8, so and so forth, right? So that's the reason it has labeled it as 0. So here in this case, the probability of 1 is high, is 0.73. So that's the reason it has labeled as 1, right? So now, if you just want to predict the classes based on the threshold, default threshold, then just use dot predict. If you want to have a probability and you want to set your own threshold, then go with this probability. It will give the both the probabilities it will give. You can consider either of these probability, and then you can classify your observations. Now, once you have this probability, in my training, in my test data set, I also have the actual values. I will compare those actual values. So this y hat is this. Okay, these are the classes. Now I'll go and compare, okay, the actuals and my predictions. And based on that, I will calculate the accuracy. Yesterday we have seen, right, based on these two variables, I can calculate the true positives, true negatives, false positives, and false negatives. And based on that, I can calculate the accuracy. So accuracy is nothing but true positives plus true negatives divided by total number of observations, right? So you need not to do it manually. So in sklearn.matrix, you have this particular function known as accuracy score. You just pass these two variables, the actuals and the predictions, and it is giving you the score. So it is saying the model is 72.5% accurate. Now, if you want to go and build a confusion matrix, so again, you have a function for it. Again, pass uh, these two variables, the actuals and the predictions. And if you want to plot it, if you just print this, it will give you a normal matrix. Okay. And if you want to print it in some visual format, then you can use this matplotlib. So this is the plot function where you can pass this particular matrix and you will get the confusion matrix like this. So here, these columns are predicted labels, and these are the actuals. So in the predicted, if it is predicting churn equal to 1 and actually it is 1, so these are my true positives. Okay. If the actual is 0, but my model is predicting as, sorry, if the actual is 1 and my model is predicting as 0, then these are false negatives. Because my model is saying negative, but actually it is 1. So these are my false negative. Here, these are known as true negatives. Okay, my prediction is also 0 and my actual is also 0. And these are my false positives. Okay, so false positives are 0. So which is good part. Okay. So this is how you can construct the confusion matrix. And based on this, you can go and uh, you can calculate the precision or the recall. But even for that, you have a function available known as classification underscore report, again in sklearn.matrix. So you pass the both variables, actuals and the predictions. It will give you the complete report. Okay. So it is giving me the precision recall for each of the classes and the F1 score. Support means overall, like for example, here 25 is the value, right, of 0. So this is 25. And for 1, this is 15, right? So this is 15. So it will give you the total count of zeros and 1, that is support. Okay. So F1 score is 0.82 for negatives and 0.42 for 1. Okay. or else you want to combine overall for the model F1 score, you have to find out. Then yesterday we have discussed, you have to calculate the precision and recall separately, and then based on that, you can calculate the F1 score. So here, if you see the precision, the recall for these negative classes, it's almost equal to 1. So if you look at this, so see, out of 25, all the 25 has been actual 25, all the 25 has been predicted correctly. So this is the recall. Yesterday, if you remember, recall, I mentioned that out of actual positives, okay, how many positives the model has predicted correctly. So that is your recall. So here for all the actual zeros, how many the model has predicted correctly. So that is complete 25, all the observations it has predicted correctly. So that's the reason my recall is 100%. Okay, it's 1. But when it comes to precision, so out of all the, for one, for let's take for one, for all the actual ones, so these are all the actual ones, how many it has predicted correctly? Okay, only 4. So the 4 by 15 is my recall for 1. So which is 0.42. Now business can take a decision like which class is more important for them, right? Is it 0 or is it 1? So in our use case, 1 is more important. My main purpose is to predict whether the customer will churn or not. So in that case, I will go and look out for a recall value, which is 0.27 for 1, which is quite low. So I may not approve this particular model. Okay. So, but overall accuracy, if you see, it is showing as good accuracy because 72.5 is kind of, a good accuracy which can be considered. But when I deep dive and when I looked into this precision and recall scores, I don't seem to this model doesn't seem to be a good model. Okay, because my main interest is to predict the churn, and that's something this model is not capable of predicting it correctly. Okay. And finally, even you can predict the log likelihood also. Again, in dot matrix, you have this particular function log underscore loss. So which is giving you as 0.6258. Okay, so this is basically a logistic regression. Now your question would be how to improve this recall. So the only one way is like you add more variables to it. Okay, yes. In the linear regression also we have seen when we went with only one single variable, our accuracy was around zero point 0.7. But when we added more variables, my accuracy of the model, overall accuracy of the model has improved, and we achieved around 0.8, 82 something, right? 82%. So similarly here also, I went with only limited variables. That's the reason probably I'm not getting a better accuracy. If you add more variables, you can improve the overall accuracy of the model. Okay, so this is what is the logistic regression. So I'll take a pause. Let me know anybody has any question. And if you go and search on Google, right, you will find multiple use cases. And I've also given you that source, right, Kaggle. So if you go and type it in Kaggle, you will find multiple use cases. So I will stress more on the concept. I will stress more on the application part in this particular course. You will get plenty of examples on the internet, okay, and on this Kaggle and other sources, okay. You can practice on the new data set, and you can see that how other people have used logistic regression to solve other problems. But you need to understand how this logistic regression works, okay, how this evaluation metric works, okay, and how you are training the model. So all that thing, it is important for you to understand at this moment. And as you will practice, you will see multiple other use cases. You will see that people have used different other ways, to pre-process the data, to prepare the data for variable selection. So that's something you have to you can understand only by practicing, okay, and by looking into various use cases. All right, so that's about logistic regression.
Sir, I have a
Yeah,
small doubt.
yeah, yeah, good.
We have three now, three evaluation metric measures, right? So which one do we need to consider?
Okay,
When
a good question. So see, it depends, as I mentioned, it depends on the use case. So for example, in this case only, so here my objective is to predict the churn. So I don't want to leave any person whose probability of churn is high, because the risk would be higher, right? If I miss out that particular customer, and eventually if that person or that customer churns, okay, then it's a loss for my business, right? So for me, predicting all the churn customers, okay, beforehand, before they churn, is my utmost objective. Okay, so for that reason, I will basically concentrate on the recall. So, what is recall? Out of all the actuals, how many observations my model is predicting correctly? Whether it is zero or a one, I can get it here, or else you can use the formula which we have discussed yesterday. This, okay, to find out for a particular uh, category what is my recall. So here they have calculated for 0 also and for 1 also. Okay. But 1 is my interest and here the recall is less. So in this particular use case, I will mostly concern on the recall factor. Now, for example, I'll take another use case. Hmm, for example, I want to segment the customers into two categories. It is not about churn. It is not about not being churn. There are two, for example, potential or non-potential customers. Okay, and I want to plan some marketing strategies to target these two segment of customers. So here my interest is both. Okay, even zero and even one. Okay, so in that case, I will go with F1 score, because here the precision is also important for me and the recall is also important for me. So I'll go with an F1 score. And for example, if I want to just uh, I want to test whether my model is good or bad, okay, in terms of how much predictive capability my model has, okay, to predict these two categories, then I will go and look into the precision. Okay, so how precisely my model is predicting these categories, right? So for different uh, use cases, you may look into different metrics. Okay. Um, for if every category is important, then we go with F1 score. Okay. If one of the category is important and my whole concentration objective is, to predict that particular category, okay, accurately, then I will just concentrate on the recall value. So in the life sciences or in the healthcare side, recall is more important. Okay, so they don't want to miss out any positive incident. Okay, for example, if any person is suffering with cancer or any other health disease, they don't want to miss out those patients. Okay, so false positives would be okay for them, but the false negative is a big risk for them. If they miss out any patient suffering with any major disease and your model is predicting that he is fine, then there is a risk of life, right? So in that case, recall becomes a very important metric to look at. Out of all the actual positives, how many positives my model is predicting correctly, okay, and how many is left out. So their higher recall value is of high importance. Okay. But overall, see, whenever you are training the model, now give this thing, to the business to take a call. Okay. You should give the entire report just like this. Okay. Give precision, give recall, give F1 score, give the accuracy score. So this is overall, if you give the classification report, they will look into every aspect. It's not like only one metric they will look at and they will take the decision. They will look at all the metrics. So, for example, in some cases, the precision might be low and the recall would be high. Is that okay? Business has to take a decision. Okay, recall is good enough. Okay, precision is also not bad. So, okay, they can approve this particular model. In some certain cases, they may want precision also to be high. In this case, if you see the precision is 1, but the recall is 0.27. So until and unless you look into both the matrix, you will not get the complete picture about the model. So it's always better from a data scientist perspective, to provide all these metrics to your business, to your stakeholders, to and explain them what each of the metrics explains, or these metrics are meant for, and then let them take the decision. Okay, whether they want to approve the model or. Okay, so I've given some description about these matrices also, okay, which you can go through and it will give you some idea about this matrix. Is that okay?
Yes.
All right. Okay, now let's jump into a new topic. Now, from here, you will kind of enjoy because these are all mathematics based algorithms and very, very innovative algorithms. Okay. This you can relate it to your with our human lives, the way we think, the way we take decisions. Based on that, these all algorithms have been discovered, and when you hear about these algorithms, you will love it. Okay, the way these algorithms functions and all. So first was the KNN, which we have already discussed. So it is called a lazy learner algorithms, and we know that why we call it as a lazy learner, because it is not learning any patterns. It is just considering the training data set as is, and then based on that training data set, it is mapping the new observations on the n-dimensional space, and then finding out the nearest neighbor, and based on that, it is doing the classification and it is doing the predictions. Okay. So it can be used for both regression and the classification, but primarily in most of the cases, we go with the classification problems. And I'm not sure if I have covered what is supervised and what is unsupervised. Can you please guys confirm? Did I cover the supervised learning and unsupervised learning, what it is?
No, sir.
Okay. So let me cover that part. So basically, machine learning is divided into two parts. Okay, supervised learning and unsupervised learning. So what is supervised learning? What is unsupervised learning? Something that we should understand now. Uh, okay. So machine learning, which we generally use for predictive analytics, are primarily divided into two categories. One is supervised, another is unsupervised. And there is one more type which is called as reinforcement learning. But basically, the reinforcement learning is still in as a into research, and it is very very less it is used in solving any business problems. It is basically is used in the gaming kind of an industry. Okay, so I'll talk about reinforcement in a bit. So let's understand what is supervised and unsupervised. So as the name suggests, okay, here these algorithm, okay, whichever comes under supervised learning, it needs some level of supervision. So when we are saying supervision, it means that we have to tell this algorithm how to learn. Okay. So that is known as supervised learning, where we are supervising this algorithm and helping that algorithm in its learning process. Okay. While in unsupervised learning, here no supervision is given to this machine learning algorithm. These algorithms learn by itself. Okay. So now what kind of supervision we are giving? So manually, we are not giving any supervision, but through data, we are providing that kind of uh, guidance to this particular algorithms. So how we are providing? Actually, in this supervised learning, we are clearly uh, distinguishing between the input variables and the output variable, and we separately giving it to this particular algorithms. So for example, if I say 2 plus 2 is equal to 4, okay, so you will get some understanding. Then I will say 3 plus 2 is equal to 5. Okay, so this is how I'm teaching you. I'm giving you the input, I'm giving also giving you the solution. Okay, output also. So here also in these particular algorithm, I'm giving the input variables and I'm giving the output variable. So observation by observation, this algorithm is understanding the relationship. And that's the reason, this is called as supervised, because at every instance, some learning is happening. Okay, like this, if I give you 20 different examples, then after 20 examples, probably you may understand this addition, okay, how it works. Okay, and that's how the kids learn, right? This is all how we as human beings we learn, and from our experiences, systematically, or probably based on our experience, the same way these algorithms have been structured. So this supervised learning is where at every observation level, I'm providing some different example to this algorithm to understand how this y is varying, okay, with respect to x, or how this x is being x, all these input variables are related to y. Okay, and then it will understand that particular relationship, and based on that, it will acquire that knowledge, and that knowledge is nothing but the model which we will use for predictions. Okay, so basically, if somebody asks what is supervised learning, supervised machine learning means where we will pass the label data to these algorithms. So label data means where we will have this output column along with the input column. So this Y column is known as labels. Okay, so if it's a classification problem, then your Y variable will capture all the classes and all the categories, right, which are associated to each of these input variables, right? So how many relevant observations you will pass to this algorithm, that much better your algorithm would learn from this data, and that much better, model you will have, for predictions. While in unsupervised learning, you will not have this output variable. There wouldn't be any target variables. You will only have the input variables. Now, your question would be what you will do with this input variables, right? When you don't have anything to predict. Sometimes you will get a problem like where you have to categorize, or where you have to group these observations into multiple categories. You do not have labels. Okay. But with some similarity or some similarity in the pattern, you may want to categorize these observations together. Okay. So in that case, I can go with an unsupervised learning. What it will do is it will try to find out the similarity between the observations, like how these observations are, um, uh, you know, aligned to each other, whether they are similar, whether they are not similar. If they are similar, then it will group. So basically, the clustering kind of algorithms falls under unsupervised learning. And the algorithms related to recommendation system. You might have seen recommendation system, right? In every uh, e-commerce website, you will find the recommendation system, right? So that recommendation system also comes under unsupervised learning. There is no label data as such that if the person watches this kind of movie, then this should be recommended. You do not have all that patterns available in your training data set. It's something the model has to learn from the uh, data itself. Okay, so it will try to find out the similar patterns inside the data and see that, okay, if somebody has watched these kind of movies, so similar to this person, how many other people are there in my data set? Okay, and it will find out those similar people, and based on that, it will give the recommendation. So there is no label data as such which will pass through to the algorithm, to provide the recommendation. Okay, so we'll understand more on that. Just for our understanding for now, now here in for unsupervised learning, we use the unlabeled data. Okay. So this KNN, these algorithms, so this is a supervised learning technique where you have to pass input variables as well as the output variable. Then only you can use this KNN algorithms. Okay, it is the most simplest machine learning algorithm. It assumes a similarity between the new case and the available cases and put the new case into the category that is most similar to the available categories, right? This we have already discussed. It can be used for regression and the classification. So these are like important points, guys. Okay, in the interview you have to create the note something like this. Okay, you just take the keyword and just write it down in one A4 sheet of paper, A4 sheet, and now these keywords would help you to explain this algorithm to the interviewer, right? If somebody says, "Can you tell me about KNN?" Then you can say that it is the simplest machine learning algorithm. It is a supervised learning technique. It does this. Okay, it finds out the similarity between the new use case and the available cases, and based on that, it will categorize the new case. And it can be used for regression, it can be used for classification. It is called as non-parametric algorithms. So what is this non-parametric? So all the mathematical based algorithms are called as non-parametric algorithm because here we don't make any assumption. And if you have seen that in the linear regression, in the logistic regression, we make certain assumption. One assumption is that we assume that all the input variables are independent, so they are not correlated to each other. Then we assume that all the numerical variables are having normal distribution. So all, and even we assume that the residuals in the linear regressions are following the normal distribution. So all that assumptions we have to make when it comes to statistical models. Statistics comes with assumption. You have seen, right? Whatever we have discussed in statistics, starting from um, uh, confidence interval till ANOVA test and chi-square test, everywhere we have assumed something, right? So those are all called as parametric um methods or parametric algorithms wherever we make certain assumptions. So this particular algorithm is called as non-parametric algorithms, which means that it does not make any assumption on the underlying data. Whatever kind of data it is, we need not to make any assumption. We can directly apply this particular algorithms. It is called as lazy learner or lazy learning algorithm because it does not learn from the training set immediately. Instead, it stores the data set and only at the time of classification or at the time of prediction, it uses that data set. In the KNN algorithm, as the training phase just stores the data, and when it gets the new data, then it classifies that data into category that is much similar to the new data. Okay, so this is in short about KNN. And if you create the notes something like this, okay, it would be easy for you to revise and you will remember all the points, right? And it will help you to construct your answer when you are in the interview. Okay, now just for your revision, so if you want to predict this and you have two classes, then it will find out the distance with every observations and then it will find out the nearest neighbor. So if you are going with k equal to 3, then it will find out three nearest neighbor to this particular point and it will go with the majority ones. Okay, it will vote. So out of those three, uh, what is the majority class in which these observations are falling? Based on that, it will classify this new class, new observation. So if you change the k value, it may change the prediction also. Okay, so for example, if you're going with k equal to 3, then the majority class is this class B because out of 3, 2 are from class B. But if you are going with k equal to 7, now your classification may change because the majorities are from class A. Okay, in overall seven nearest neighbors. So this is how, in this case, considered as a hyperparameter, and based on, you have to choose the k value, which is giving you the better predictions or higher accuracy. Okay, so for distance measure, we basically take Euclidean distance uh, between the 2 points. So if you have the coordinates for 2 points, then you can calculate the distance between that 2 points using this Euclidean distance measure. Okay, this also we have discussed. Yeah, so the step-by-step process is you have to select the uh, k value, then you go and calculate the Euclidean distance and identify those k number of neighbors. And then among those k neighbors, count the number of data points in each category and then assign the new data point to that category, which in which the number of neighbors are is maximum. Okay, and that's all. And your prediction is ready. Okay, so there is no training as such. For every prediction, it has to go through all these steps, to predict the class or to predict the output variable. Okay, so that's about KNN. So after that, let's get into naive Bayes. Okay, so you must be remembering this Bayes word, right? Where did we hear this Bayes word, guys? Can you remember this word Bayes we have used somewhere? Huh? Sorry. An answer is also in front of you. So we have heard this in probability classes, right? Bayes theorem. So why, where we use this Bayes theorem, guys, for calculating what? Just try to remember, okay? So in probability, we have used this Bayes theorem, and this Bayes theorem is used for one particular purpose, right? To calculate some kind of probability. What is that probability? Conditional probability, right? So if you want to see what is that particular formula, this is that formula. Okay, if you can recall. So this is Bayes law, Bayes rule, Bayes theorem. Okay, it is called by different names. So basically, this is the theorem, okay, which we use to calculate the conditional probability. If you want to find out the probability of event A, given the event B has occurred, then this is the formula where this particular term is known as posterior probability, probability of hypothesis A on the observed events B. So whether this particular event would occur or not occur, here it is conditioned on this particular event B, and that's what we have to calculate. Okay, so where probability of B given A is called as likelihood probability, PA is called as prior probability, and PB is called as marginal probability. Okay, so this is your Bayes theorem. And this theorem, this particular algorithm has been framed. Okay. Now see, in our real life also, these unknowingly, these conditional probability works in our mind. Okay. So for example, if there is a cloudy weather, right, and we 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 automatically we kind of we get into a conclusion now it will rain. Now, rain has been conditioned based on the weather, whether it is cloudy or not. Okay, and based on that, your brain is telling you now it will rain. How your brain is confidently telling that okay now it's going to rain and you will take all the preventive measures, right? Because you have experienced that. Okay, you have experienced that in the past when there is a cloud, there is a rain. When there is a cloud, there is a rain, right? Sometimes you have seen that okay. Uh, even if it is cloudy, if there is too much of windstorm, okay, too much of breeze is there, sometimes rain would not come because the cloud will go away, because of that wind, right? So there, the probability, your mind says that now probably it may not rain because there is too much of wind. Okay. So how you arrive to all these things, because you have seen that and your brain knows that if some event is occurring, based on that whether other event would occur or not, right? Kids do something, right? We say that now he's doing this, so that means something he will do now. Okay, so every time we will predict something based on certain events which have occurred, right? The same way, the same logic people have used here, and coined this particular algorithm. If we know in prior what all events have occurred, based on that we would be in a better shape to predict whether a certain event would occur or not. For example, if I want to predict whether the customer will buy my product or not. Okay. So it happens in the e-commerce digital analytics. Let's suppose a person is coming from a particular website and landing onto your uh, e-commerce page. Okay. And then if let's suppose he is going and searching about a particular product, and let's suppose he has spent around 5 minutes there on search. Okay. And then he randomly moved into some other page, then other page, then other page. So with this behavior, can you able to predict like how serious that person is and whether what is the probability that he will buy the product? Okay. So now you take this particular example and relate to a retail store, okay, brick and mortar store, where you have a store and one person is entering into your store and he's also doing the same thing. Sometimes he's going and looking into, we call it as a window shopping, right? Sometimes he's going and looking into certain kind of products, and then he is getting into some other products. So basically his intention is not to buy a one particular product. He has just come to explore what all things are there. So you have seen that these guys, the storekeepers, they will, once they will check, okay, are you looking out for something, right? If he doesn't answer, then they will take it light. Okay, now they will feel that okay, this person has come just like to watch what kind of products we have, and he is not serious, right? And they will not give that importance to that kind, those kind of people. While a people who is coming and specifically looking out for certain products, so definitely his chance of buying a product would be high, and they will focus more on those customers. So what is happening in overall all these things, right? Here, based on the behavior, based on certain events, you are predicting, okay, whether what the final event would be, right? Whether the person will purchase or not purchase. The same pattern, people are applying on the e-commerce digital field, because there we can track the footprints of the customers, from where he's coming, what he's searching, how much time he's spending on a particular page, how he's navigating from one page to another page. So all that thing information would be there, and if we capture all that thing, based on that we can able to make the prediction whether he will make the purchase or not. And how we will do it, again through historical data. In the historical data also there would be similar patterns available, and we will also have the output variable also available, whether that person who has done all these things and navigated and explored all these things, whether that person, similar person, has purchased any product in the past or not. Okay. And based on that the model will learn all that patterns, and based on that it can able to predict for the uh, new events. So you have seen, right, in the real life we are, knowing or unknowingly, we are kind of calculating that conditional probability, and based on that we are taking the decisions and we are taking preventive measures. Similar way, in the business context, okay, we can use this particular algorithm. What it will do is it will take all the historical events into consideration. It will take the data, and based on that it will acquire that knowledge, and that whole conditional probability, okay, that would convert as a knowledge, and that would be your model. Okay. So here the model is not an equation, it is a probability score, right? So based on that probability equation, Okay, this model can able to predict the probability of the events, whether that will occur or not occur, condition to other events. Okay, so now what is a naive Bayes? Naive Bayes algorithm is a supervised learning algorithm, and why we call it as a naive Bayes? Okay, first of all, uh, I don't know whether that is mentioned somewhere here or not. It is not mentioned. So Bayes we understood. This word has been derived from Bayes theorem. And what is naive? Naive in English word means simple, okay, or simple or basic. So here we we have multiple input variables x1, x2, x3, x4, and then we have y. So here we are predicting y conditioned on x1, x2, x3, and x4. But here we are taking one assumption that x1 and x2 and x3 and x4, these are all independent. These are not conditioned to each other. But there could be a chance that, okay, these events could also be conditioned to each other. Okay, so for example, a person coming from a particular website, okay, generally they may spend more time on your website. There could be a chance, right? But here in this particular algorithm, we are not considering all that kind of relationship between these independent variables, these input variables. We are considering them as independent. Okay, so that's the reason it is called as naive. When when even we have to consider the relationship between these variables also how they are related to each other. Now for that we have much more advanced algorithms. Okay, so we have recurrent neural networks, we have LSTMs, which will also understand how these variables are also related to each other. What is the probability that this x3 would occur provided that x1 or x2 has occurred? Okay, so even that also it will take into consideration, but for now just this algorithm will find out the probability of this y condition to each of these input variables. So that's the reason it is called as naive Bayes. Okay. Okay, so which is based on Bayes theorem and used for solving classification problem. Now this particular algorithm is only meant for classification problem because this is this algorithm is only capable of calculating the probability, and wherever the probability comes, it is related to classification only. Remember that. Okay, so wherever the algorithm is capable of only calculating the probability, so that means that particular algorithm is can be used only for classification problems. Because when it comes to probability, it is about whether that particular event would occur or not. So you can categorize that event to a particular category. So in that case, so regression problem, this is not a suitable algorithm. And now this particular algorithm is widely used for text classification. Now you might have seen in Outlook or in Gmail, automatically certain emails will go and flow and get stored into your junk folder, right? Into spam folder. How that is happening? So there is these kind of probabilistic algorithms are taking those decisions, whether that particular email is a spam email or whether it is a good email. Now let me ask you one question here. Okay, let's suppose you have to make that decision. Okay, so earlier we used to do that, right? Earlier we automatically our emails. I don't know. I'm talking about uh, early 1990s. Okay, at that time, automatically the emails um were not flowing into the junk folder. Okay, so we used to manually drag and drop or move those or delete those or move those emails into a junk folder. So at that time, or if you have to do it manually, how you will do it? How you will categorize an email, whether it is a good email or whether it is a junk email or a spam email? How you will categorize that manually? Anybody?
Based on the sender email ID
Sender. Okay, fine. That is one of the ways.
and the links in the email.
links, and what else?
Keywords.
Keywords. Exactly.
The text and keywords.
Text and keywords. Basically, it's all about usually, okay, the first instead of senders, of course, okay, if you are not opening the email just by looking at from whom you receive that email, probably you will get some idea. But if let's suppose if it is a name, right? If it is Shrikant at the gmail.com. So Shrikant could be your friend, could be your relative, could be your trainer, or could be somebody else, who is selling some waste product. Okay. So until unless you open that email and read the text, you cannot take the decision, right? And to genuinely and to accurately classify or categorize the emails, definitely it is always good, to open the email and then check whether it is a junk email or a good email. So now when you are reading the text, when you are open the email, you will go through the body text, right? And in that body text, you will see certain keywords. If the first sentence is like, I'm glad and I'm happy to offer you this particular thing, this lottery or this uh, product in free. At that time, I remember, we used to get a lot of emails like, congratulations, you have won $1 million or something, and people even got into that kind of fraud, right? And so later we got to know that all those emails are fraud emails. So sometimes, based on your experience, you will understand that this is a junk email, but major of the cases, by reading the text, you will get to know that, okay, this is some kind of a junk email. So basically, certain keywords like, okay, congratulations, you won. So these are the certain keywords which classify that email is a junk email, or uh, sale or discount or the offer. So these are some of the keywords, which you will consider that, okay, if it contains in an email, then it is definitely a junk email, right? That is how your brain is tuned. So here, whether that mail is a spam or a ham, ham means a good email, whether it is a spam or a ham is conditioned based on the keywords which are present in your email or in that particular text. Now, just think about from a Bayes theorem perspective. If in a particular email, certain keywords are present, okay, so then what is the chance that that particular email will be considered as a junk email? Okay, so here, as I mentioned, these emails are conditioned based on these text which is present in the email, right? So by looking at all the historical emails and the way they have been categorized, you can train this particular algorithm, and this algorithm will acquire that knowledge. Like, if these keywords are there, then what is the probability that it can be categorized as junk email? So that is known as conditional probability, right? So now, with this particular mechanism, people started using this particular Naive algorithm to classify the text. So now you must be thinking that how this text can be converted into a structured data, because this is a kind of a text, right? And here we need a structured data which is more of a tabular format. So what the people have done is they have extracted the keywords from the text and then they converted that into a structured data. For example, a one particular column could be a one keyword like sale, okay, or offer or discount, okay. Now, if it is a junk email, now this is your why. If it is a junk email, then it will be labeled as one, and and if these words are present, then they will be marked as one. Otherwise, if that word is not there, it will be marked as zero. Now, like that, you have to prepare your text into this kind of structured data. So let's suppose this is document one, this is document two, this is document three. So a lot of text processing you need to do, and you need to extract all these keywords And this all comes under natural language processing, okay, which we will discuss later. Okay, so that NLP, you have to use it here, natural language processing. And in this natural language processing, you can within with the use of few line of codes, you can extract important keywords from the text. It will remove all the preposition, conjunction, all the uh, words which doesn't make any, which will not give you any information about the document. Those words will be dropped out. Only the certain keywords will be extracted, which will give you more information about that particular document. Okay, so with the help of NLP, I can convert my text data into this kind of structured data, and then I will feed it to this Naive base. So that means if this event occurred, then what is the probability that this particular event would occur? So if the sale word is there in my document, if the offer word is there in my document, what is the probability that that particular document is considered as a junk document or a junk email? Okay. So for that, when they have tried this for text classification, it worked very well. Because see, now also, let's suppose I give you 5 or 6 books, okay, and I will just tear off the cover page, okay, and I'll give it to you. I'll say that now categorize these documents. Okay, what you will do, you will first read the book. Okay, initial few pages, if you read it based on the keywords. Let's suppose if first book is talking more about data. Okay, so then you can categorize that document as a book, as a data book. If second document is talking about politics, okay, about the government, about the policies and all those things, then you can categorize that particular document as a policy document or government related document or something. If the third document is more about sports, then you can categorize it as sports, right? So we as human beings, we how we are, again, it is based on some logic we are categorizing that book. Then what is that logic? People thought about it and they felt that okay, now this is more about uh, condition probability, like if these events have occurred, then based on that, people are taking a decision. Okay, so here also, if these kind of keywords are existing in the document, then I have categorized that document related to that particular keyword. So um, so based on that logic, now Naive people are using it for text classification. So even you might have heard about sentiment analysis, right? We get a lot of feedback from the customer. So on the e-commerce website, if you look at the Amazon, people have given a lot of reviews about the product, right? And now these businesses, they are reviewing and they are analyzing these customer reviews and the feedback to understand how the people are perceiving their product and their services, and where should they need to focus to improve their product and services furthermore. Okay, so for that also, we can use this Naive base to classify a feedback, whether it is positive or negative, or whether it is neutral. So for that also, you need to have a training data set where you can consider certain list of a certain number of feedback or reviews, and it should be labeled whether which feedback is negative, which feedback is positive, and then you have to give it to this algorithm, and then algorithm will understand if a keyword like happy, excited, um, I was very much delighted, so it was great, good. If these kind of words are there in a feedback, then generally it is a positive feedback. If it's like bad, worst, disgusting, if these kind of negative words are coming, then mostly it is a negative sentiment, right? So that learning this algorithm will do, and based on that, if any new feedback is coming, then it will be able to classify that to negative or positive. Okay, so yeah, so that's the reason. So if in the interview, if anyone will ask like, have you done any document classification? Have you done any sentiment analysis? Have you done any test classification? Then you can refer to this particular algorithm. You can say that, yes, I have done it and I've used the Naive Bayes algorithm. Okay. So it is one of the simple and the most effective classification algorithm which helps in building the fast machine learning model that can make quick predictions. So when you have to train the model quickly, then this could be one of your choice, okay, which you can use, for training any classification model. Now this is called as probabilistic algorithm or probabilistic classifier, which means it predicts on the basis of probability of an event or of an object. Some popular examples are spam filtration, as I mentioned, sentiment analysis, and classifying any articles. Though they have mentioned all these examples related to the text, but it can also be used for non-text problems also, non-textual problems also. Okay, yeah. So here it is mentioned, it is called naive because it assumes that the occurrence of a certain feature is independent of the occurrence of other features. As I mentioned, all the input features, all the input variables, they are independent. They are not impacting or they are not affecting each other. Okay, so that's the kind of assumption we will make here. Okay, such as if the fruit is identified on the basis of color, shape, and taste, then the red, spherical, and sweet fruit is recognized as an apple. And hence, each feature individually contributes to identify that it is an apple without depending on each other. So, like red, spherical, sweet, each of these words will basically help you to identify that particular fruit, which is your target variable, whether it is an apple or an orange or a grape, right? So every variable is conditioned onto this particular output variable. But this red, spherical, this sweet, these three variables, they are not depend on each other. Okay. So that's the kind of assumption we'll make when we are training this particular algorithms. Okay. We have discussed this. So how we will go step by step is we will convert the given data set into a frequency table. What do you mean by frequency table here? So frequency table means, for example, x1, x2, x3, and we have y. Okay. So here, firstly, we need to understand, for example, for let's suppose this is category one. For category one, how many times this particular event x1 has occurred? Okay, so we have this will capture from the original data, it will capture that kind of frequency, it will aggregate it. For C1, how many times the X2 has occurred, X3 has occurred. Okay, if you consider this text classification use case, for example, if it's positive is one of the category. Okay, for positive, how many times this particular keyword has come in these kind of documents which have been categorized as positive. So like that, it will create the frequency table, and we will do one manual exercise also. Okay, in the class, I will give you one exercise which will do it together. So we will construct that frequency table, and based on that frequency table, it will calculate, it will generate the likelihood table. What is this likelihood table means? So if you remember, mm, probability matrix we have discussed, right, in the probability class. So firstly, there was a frequency table, and based on that frequency table, we have generated the probabilities. Okay, you can refer to the previous class. So similar kind of table, this algorithm will generate in the backend. Okay, for every incident, for every event, okay, it will calculate the probability. So what is the probability that this event has occurred? Then this event has also occurred. Okay, so you can refer to that probability class. So that kind of a likelihood table, it will generate to find out the probabilities of a given feature. Okay. Now, once that particular table has been generated, now based on that, it will apply the Bayes theorem to calculate the posterior probability. So posterior probability would be probability of y given this x1, x2, x3 like this. Okay. So this is your posterior probability. What is the probability that y would, so you can, if it is categories, then y is equal to positive given that x1, x2, x3. So this is your posterior probability based on the Bayes theorem. It will calculate this. So we will do one exercise manually. Okay, I'll give you certain scenarios, and then we will calculate the posterior probability. In that way, you will understand how this Naive-Bayes algorithm, works and how it predicts the output variable. Okay. So here I will stop, and tomorrow we will take that exercise. We'll do it, and then we will also see one use case using Python. Okay. So let me know anybody has any question on this Naive-Bayes algorithm. No questions? As if you don't ask questions, I don't know, how to take it. Sometimes I feel that it's all clear. Sometimes I feel that nothing is clear.
So do we have evaluation metrics also for this?
Yes, evaluation matrix is standard. Now I said this particular Naive-Bayes algorithm is used for classification. So whatever matrix we have considered in this particular logistic regression, where we have solved one classification problem, the same evaluation matrix, we will use it here also. So evaluation matrix would be standard. So we have seen for numerical prediction, we use RMSE, we used R square. That is common, whatever algorithm you use, if you are using it for numerical prediction, you will generally go with the same evaluation matrix. And if you are going with a classification, there is again separate set of evaluation metrics which you will consider for all the classification problems. So that will not change based on the algorithm. Okay, so that will be fixed.
Okay.
Yeah. So evaluation matrix is what? You will take the actuals and you will take the predictions and you will compare. It doesn't matter, from where these predictions are coming. You can use Naive-Bayes, you can use KNN, you can use logistic regression. It doesn't matter. If you have the predictions, if you have the actuals, you have to compare that and you have to evaluate how good your predictions are. You have to use the same evaluation criteria. You have to use the same evaluation metrics. It will not change based on the algorithm. Okay, so that's it for today, guys. Okay. Um, I will check with you guys if tomorrow if you are okay to have a class. Okay, I'll send a message on Telegram. So please confirm if you most of people if you are okay, then we will have a class tomorrow. So this is how I can compensate whatever breaks I have taken. Okay, so I'll try to compensate during the weekend. Okay. All right, guys. Then thank you. Have a nice weekend. Take care.